Okay, so truth of the matter is, I didn't try to make two videos. I just hit the wrong button, and I wasn't gonna make a third one. Well, a fourth one, which is what I'm doing now. But anyway, let's continue with number 2 here. Notice that number 2 is in what's called vertex form. So automatically, we can tell that the vertex here on number 2 is simply 1, 2. H, K. Okay, you see that H is on the inside, K is on the outside. We don't want negative H, or it's not necessarily negative. The short version is just whatever sign it is on the inside, you take the opposite of it. So see how that was a -1 and that's a +1? But you don't do that to K. Anytime in algebra, you're taking something out of parentheses, it changes signs for the most part. And so that's a -1, so it became a +1. But this K, or this 2 here, was not in a parenthesis, so it stayed the same. So just keep that in mind. The axis of symmetry is going to be always x equals whatever that is, or x equals h according to this. A is the number in front, and notice it's not negative, so we know that it opens up. And this is just supposed to be up. And this is just information that's going to help us graph. And if we put 0 in here, we're going to get 1 plus 3. So 0, 3 is our y-intercept. And so we can take that information and we can graph this to figure out what it looks like. By the way, since it's opened up, our vertex is a minimum. If we go back to our little picture here and kind of restart, we can say that our vertex is 1, 2. So I go over 1 and I go up 2. That's my vertex right there. My y-intercept is 0, up 3. Boom. My axis of symmetry is x equals 1, which is just a coincidence that it's the same thing as before. It's just a coincidence. Don't be thinking it's always going to be 1. And so again, since that's symmetrical, I can do that. Boom. Now, if this opens up and looks like this, tell me, what are my solutions or my y-intercepts? Shouldn't they be imaginary? Right? Shouldn't they be imaginary? Let's take a look and see. How do we solve something that looks like this? Well, I'm going to put 0 in for y. That's what you do, remember? That's what the notes say. And if it looks like this, we got to get everything away from the parentheses. And so if it bothers you that things are switched around, let me go ahead and turn it around for you. I just flipped the whole equation so everything can be on the side you used to. You got to take the square root of both sides, and you get x minus 1 equals plus or minus the square root of -2. However, we can't have a -2, so that becomes plus or minus I square root of 2. Remember, you get that imaginary number, plus 1, and you get x equals 1 plus or minus I square root of 2. But we knew it was going to be like this because when we graphed this ugly looking graph right here, that we knew that it didn't cross the x-axis. Remember, solving a quadratic equation is simply finding the places where it crosses the x-axis. Alright? Alright. I got a graphing calculator here. I just want to show y'all a couple of things, couple of problems of how to use a graphing calculator. Well, not necessarily how, but the advantages, I guess, of using one. A graphing calculator can tell us a lot about the problems, and there are several of us I've seen walking around with these, and so you already know the benefits, I'd imagine. But if I go to y equals, and as long as my equation is solved for y, and I know how to input it into the calculator, it should be okay. What if it's not solved for y? Solve it for y. Put everything to one side, write it in descending order, and now I'm going to put x squared in. So I actually have to hit this alpha button, and actually I don't really need the alpha. I can just hit that x length, this xt, whatever. And then I hit the squared, minus 6, that button again, plus 11. All right, so I put x squared minus 6x plus 11 in. Then I go over here and I hit graph. And I get that equation, right there. So what would the solutions be? What would the zeros be? Wouldn't they be imaginary because we don't cross the x-axis, right? Now I'm going to show you how this can tell me what the vertex is, or the maximum or the minimum. I can go over here to see where it says calculate. But in order to get to calculate, I had to hit the blue button and see it says value, 0, minimum, maximum. Which one do we have in that problem? We have a minimum because it opens upward. So I hit enter. And it says left bound. So I'm tabbing to the right because it was up there to the left. And I want to get close on the left hand side of the vertex. Just hit enter. What the calculator is doing is it's going to do a little bit of math. It's going to do an average. Then it says right bound, so I'm on the right hand side of that point. And then it says guess. It's basically now about to do a calculation. Normally when it's like this, and it does this from time to time, I didn't get a good guess, I guess. When it's like this, 2.99999, we never really want to guesstimate, but we can assume that that really meant 3. Okay, so it's actually telling you that the vertex here is 3, 2. The y is 2 and the x is 3. Okay, that's just a way to find it. Find the vertex, and of course the axis of symmetry would be the same as x equals 3, and so on. Again, we don't have any solutions, so we don't get to see where it crosses the x-axis. If we go back to y equals and we hit clear, and then we put another equation in, let's do negative 3x squared plus 5. Okay, not minus. Don't hit the minus button. That's down here. There's a difference between the minus and the negative. Okay, so be careful. If it's negative, hit the negative button. And of course, since a is negative, it opens down, right? It should do that. All right, let's see if we can find the zeros. We also have a maximum, right? But let's see if we can find the zero. So I go hit second, and I go hit trace or calc right here. And I want to find a 0. You see that? That means the solutions are the roots. So I hit 0. And it says left bound. You see where it's flashing at? So I get to pick which point I want to find first. Left bound. Whichever one, I need to find the left-hand side of that point. So if it's this point, I want the left-hand side of that point. And so I hit either this one or the other one. And the right-hand side of that same point. Enter. And I hit guess. And you can see that when y equals 0, now this don't have 999 all the way through. So it's telling me that it's a decimal. Negative 1.29 or negative 1.3. All right. So that would be that one right there. That would be that particular 0. And so say I want to do it again. I'm going to tab over this side, and the left-hand side of this point is over here. Let's get on top of it this time. And then the right-hand side of this point is over here. Well, I'm going to just stay right there. And then now I'm going to say guess. Okay, it didn't like that. It didn't like that. You got to move it. So let's go back to y equals. Let's go to graph. And let's calculate. All right, 0. So left bound is on the left-hand side of that point. And the right bound is going to be the right-hand side of that point. And you get positive 1.29 or 1.3. So you notice you don't get whole numbers. But I'm trying to give you the idea. Say you were working this on your homework or something and you didn't know if you got it right. If you had a graphing calculator, you can put it in there and see if that is the same thing as the decimal you got in the quadratic formula, or completing a square, or whatever it is. This number should be the same thing as what you get whenever you put it in the calculator and see if you get a decimal. We can do more with this in class if you got questions.